Solving logarithmic equations. A logarithmic equation is one that involves logarithm. Example, solve for x in the following. So here, we have to convert this to index form. We said this is our base here, and logarithm is the index, which is minus 3. In index form, we shall have 3 to the power minus 3 is equals to x. So I'm saying that x equals to 3 to the minus 3. X is equals to 1 all over 3 cubed. X is equals to 1 all over 27. Let's look at the second one. Log to base x of 81 is equals to 4. This is our base, and this is the logarithm 4. We're saying here that x to the 4th is equals to 81. I take 4th root on both sides. X will be equals to 3. So we are given this one 2 to the power log to base 3 of x. All of this gives us 64. Let's express this in the same base. This is 2 log to the base 3 of x is equals to 2 to the 6th, because 64 is equals to 2 raised to the power 6. The base is the same. We can then equate the logarithms. Log to the base 3 of x is equals to 6. This is my base here, and this is my index or logarithm. So x there is equals to 3 to the 6th. Take note here that our standard logarithm is base 10. And normally, when the base is not indicated, consider the base to be the standard base, which is base 10. So here I have log base 10. We just say log x minus 8 is equals to logarithm of x minus 8 is equals to 1 minus logarithm of x plus 1. So I have to bring log on both sides. I have logarithm of x minus 8 plus logarithm of x plus 1 is equals to 1. Now, here I'm adding two logarithms, and remember the laws of logarithms were multiplying two numbers. This will give us logarithm of x minus 8 times x plus 1 is equals to 1. Now I have to change this into index form. Our base there is base 10. This will give us x minus 8 factor of x plus 1 is equals to 10 raised to the power 1. So x minus 8 factor of x plus 1 is equals to 10. I have to open the brackets here. This will give us x squared plus x minus 8x minus 8 is equals to 10. Simplify this. X squared minus 7x minus 8 is equals to 10. X squared minus 7x minus 8 minus 10 is equals to 0. X squared minus 7x minus 18 is equals to 0. Now, solving this quadratically, we look for two numbers that when multiplied will give us minus 18, and when added will give us b minus 7. Those two numbers are minus 9 and 2. So here I will say x squared minus 9x plus 2x minus 18 is equals to 0. So x is common. X factor of x minus 9 plus 2 factor of x minus 9 is equals to 0. So x minus 9 is common. Factor of x plus 2 is equals to 0. So we said if two numbers are multiplied, and the product is 0, therefore means that one of the numbers should be equal to 0. So we say x minus 9 is equal to 0, x that is equal to 9. Or it is x plus 2 that is equal to 0. So we say x that is equal to minus 2. Let's look at this problem here. Log base 3 of x squared minus 2x minus 6 is equal to 2. Now, I start by removing logarithm. This is my base, and this is the power or the logarithm. So I'm saying here that x squared minus 2x minus 6 is equals to 3 raised to the power 2. X squared minus 2x minus 6 is equals to 9. X squared minus 2x minus 6 minus 9 is equals to 0. X squared minus 2x minus 15 is equals to 0. We then have to solve this quadratically. Two numbers that when multiplied gives us minus 15, and when added give us minus 2. What are those two numbers? I have minus 5 and 3. So I use it to factorize this. X squared minus 5x plus 3x minus 15 is equal to 0. X is common. X minus 5 plus 3 is common. X minus 5. X minus 5 is common. I write it once. X minus 5 factor of x plus 3 equals to 0. So now, these two numbers are multiplied to give us 0. It means that one of them should be equal to 0. So I say x minus 5 is equal to 0. So I have the x that is equal to 5, or it could be x plus 3 that is equal to 0. I have the x equals to minus 3. If we are given this problem, log base 4 of x is equals to minus 2. This is our base and this is our logarithm. So we are saying here that x is equals to 4 raised to the power minus 2. X is equals to 1 over 4 squared. X equals to 1 over 16.